Hi guys and welcome back to the Ace Academy. In the first part of this video, we are going to be focusing solely on sketching the hyperbola using a given equation. On your screen right now, you can see that I have a blank Cartesian plane as well as two equations for two individual and unique hyperbolas. So let's go ahead and start off with the red function, and that is f of x is equal to 3 over x plus 2 plus 3. Now, when sketching a hyperbola, we are going to look at some of the important points of the hyperbola. And those are the features that allow us to define a hyperbola simply. And that is your horizontal asymptote, your vertical asymptote, as well as the shape of the hyperbola. So let's look at this equation, right? If I inspect this equation, I can see that the q value using the equation y is equal to a over x minus p plus q as our standard formula. We can see that our q value is positive 3. And we know when it comes to the hyperbola, the q value is in fact the y value of our horizontal asymptote. So if q is positive 3, that means that our horizontal asymptote would lie at y is equal to positive 3. So I am going to estimate where positive 3 would be on this Cartesian plane, and I'm simply going to sketch in my horizontal asymptote. I'm also going to label that as positive 3, or y is equal to positive 3. Let's look at the second bit of information we can get from this equation, and that is that this hyperbola has been shifted to the left by 2 units because it's x plus 2. Looking at our standard equation, we can see that the value of p, the x value of our horizontal asymptote, is -1 times that constant that is being added to the x value in the denominator. So that will be -1 times positive 2, which would be -2. So I'm going to estimate that and plot that in on my Cartesian plane. I'm going to label this as x is equal to -2. The next bit of information that I need to obtain from my equation is the shape of the function. And that can be obtained using the a value of this function, or the a value in this function, which is the number that is in the numerator of the fraction, and that is positive 3. Because my a value is positive, I know that my function is going to lie in the first and third quadrant that is created using my asymptotes. So I can just simply sketch that in. And there you have it. That's how I would sketch the function of f. Of course, I would have to label that, so I'm just going to label that f of x. And there we are. That is the graph of f. Now let's go ahead and look at how we would plot the graph of g. Now, g has the equation g of x is equal to -1 over x minus 1 minus 2. I'm going to follow the exact same procedure in order to plot this function. And that would be simply, I would need to put in my asymptotes first. So looking at our standard equation for a hyperbola, we can see that the q value is in fact the y value of the horizontal asymptote. So in the case of the equation of g, we can see that the q value is in fact -2. I simply have to sketch in a horizontal line at y is equal to -2. So I'm going to estimate that and sketch it in. Let's label that y is equal to -2. Okay, now we're going to go ahead and plot in the vertical asymptote, which, if we look at our standard equation, would be -1 times the p value. So looking at the equation of g, that will be -1 times -1, which would be positive 1. I can go ahead and sketch that in. X is equal to positive 1. My next step to obtain this hyperbola, or the graph of g, would be for me to analyze its shape. Let's look at the numerator of this fraction. I have -1 as an a value. Now, the a value is less than 0, meaning it's a negative number, and we know that when a is negative, we are going to have a function in the second and fourth quadrant that are created by our horizontal asymptote. So let's go ahead and sketch that in. And there you have it, guys. That is as simple as it gets when it comes to sketching a hyperbola using a given equation. Okay guys, so we are now moving on to obtaining the equation of the hyperbola using a given sketch. And as you guys can see, I have sketched two different hyperbolas on a Cartesian plane, and we are now going to work with that in order to obtain equations for both these hyperbolas. The first hyperbola we are going to look at is the graph of f. And this is a function that has been sketched in red. So the first step in order to find the equation of this function would be for us to write the standard equation of a hyperbola. And that is f of x is equal to a over x minus p plus q. And we are simply going to solve for all the variables in this formula. Let's look at the information that has been given to us for the graph of f. We can see that the graph of f has a horizontal asymptote at -2, which means it's been shifted downwards by 2 units. So we can simply say that q is equal to -2. Let's go ahead and look at the vertical asymptote. We have been given an x value of -4 for the vertical asymptote of this function. We can simply say that p is equal to -4. Now let's look at the shape of this function. We can see that this function lies in the second and fourth quadrant that has been created by its vertical and horizontal asymptote, which means that this function is going to have a -a value. That's a little hint to show us that we are moving in the right direction. We are now going to go ahead and substitute these variables into the formula, and we are going to solve for the unknown variable in this function or in this equation, which would be the value of a. So if I'm substituting in these points into, if I'm substituting in these values into my equation, I would get f of x is equal to a over x minus -4, substituting in -4 for p, plus -2. If I were to simplify that, I would obtain the equation f of x is equal to a over x plus 4 minus 2. Hey, there's still one variable that we haven't solved for yet. Now, in order to solve for the variable a that is an unknown, we are going to need a point on this function. And we can see that we have been given a point for the y-intercept of this function, and that would lie at 0 and -3.5. I can substitute that point into my equation to solve for a. Substituting in 0 and -3.5 into my equation, I would get -3.5 is equal to a over 0 plus 4 minus 2. I can now go ahead and simplify this equation in order to solve for a. Bringing -2 over the equal to sign, I would get -3.5 plus 2 is equal to a over 4. Simplifying further, I would obtain -1.5 is equal to a over 4. I can then multiply both sides by 4. Expanding this formula further, I would obtain 4 times -1.5 is equal to a. And expanding further, 4 times -1.5 is equal to -6. So therefore, a is equal to -6. I can then go ahead and substitute a into my formula, and I should obtain an equation for the function of x. So let's go ahead and do that together. F of x is equal to -6 over x plus 4 minus 2. And that is the formula for the graph of f. Okay guys, we are now going to move on to obtaining the equation for the graph of g. As you guys can see, we have been given a bit of information right here, which tells us that the a value for this function is +3. So let's go ahead and repeat the exact same procedure we did for the graph of f in order to obtain the equation for the graph of g. We are going to go ahead and write down the standard formula for this function, and that would be g of x is equal to a over x minus p plus q. Now let's go ahead and list the value of all the variables in this equation. We know that the value of a is equal to positive 3. Let's go ahead and look at any other information that has been given to us for this function. We can see that the value for its horizontal asymptote is a y value of positive 3. So we can say the q value is equal to positive 3. The only other variable that is unaccounted for in this equation is the value of p. That has not been given to us. We have no idea what the value of p is. That means that we are now going to have to solve for the value of p in order to complete this equation. So let's go ahead and substitute all the variables that we know into this formula. We are going to obtain the equation of g of x is equal to 3 over x minus p plus q. Okay? We also have a point on this function that is known, and that is the x-intercept of this function, which lies at a coordinate of 4 and 0. Let's go ahead and substitute in this coordinate into our equation. 0 is equal to 3 over 4 minus p plus 3. Now we can go ahead and solve this equation in order to obtain the value for p. Substituting and manipulating, if I move the value of positive 3 over the equal to sign, I would get negative 3 is equal to 3 over 4 minus p. Multiplying both sides of this equation by 4 minus p, I would obtain negative 3 times 4 minus p is equal to positive 3. Dividing both sides by negative 3, I would obtain 4 minus p is equal to negative 1. And now transposing the 4 over the equal to sign, I would get negative p is equal to negative 1 minus 4, and I would obtain p is equal to positive 5. I can now substitute in the values of each variable into my formula, and I would obtain the equation for g. So simply put, g of x is equal to 3 over x minus 5 plus 3. And that is as simple as it gets, guys. That's it for me. All the best, and I will see you in the next one.